Alright, so I decided we're just going to go into physics because I need to review the material and there's a lot to cover, so we can work on it for a little while. In physics, as far as what I've seen on the ASP, you have circuits, kinematics, Bernoulli, probably spelled that wrong. Conservation of momentum. And some random volume problems that I'll just say are in the physics realm. So I figured, why not start with the first one, circuits. It's material we've covered, but it's been a little bit. So, what do you need to know about circuits? First thing is it would be nice to make a little chart of what is what, since if you're not familiar, it's kind of confusing. They use E or V to represent voltage, and the units are in volts, and you'll commonly see that as a V. Next is current, which is usually I, and that's going to be in amps, and they might just represent it with an A. Next is resistance, so R. And then that will be in ohms. It is usually a capital omega. Last is power. It's going to be in watts. It's going to have just a big W. So this would be the symbol, the name, the unit description, and then the way to write the units. So the unit name, I guess, unit symbol. Okay? Then we have our standard equation. So you have V is equal to IR, and you have power is equal to IV. I'm going to use V since if I start writing E, I'll accidentally write it as V at some point. So I'll just keep with what I know best. There are also two types of circuits. There are circuits that have resistors in parallel, so which will look like this. R1, R2, R3. And the way that you sum those up is 1 over R total the total resistance of that circuit. So once you've found this out, you can replace this with a simpler circuit that just has R total in it, and it's the only resistor. 1 over R1 plus 1 over R2 plus 1 over R3. Okay? You have to be careful. Typically what you will do is you'll put all these fractions into your calculator, add them up, and then you'll get 1 over RT is equal to some number. And then you're going to take both sides, divide by 1, divide 1 by each side, and that will give you RT is equal to 1 over whatever that number is that you got when you added all these together. Okay? The other type of circuit is resistors in series. And that would look like this. These little bars right here represent like a battery. These aren't AC circuits, they're just DC circuits. But they're much simpler to work with. So R1, R2, R3, R total is equal to R1 plus R2 plus R3. A lot simpler. And so what that gives you the ability to do is when you write V equals IR, this is true for every piece of the circuit. So if you wanted to just look at this resistor and you knew the current going through it, which for a circuit in series, it's the same current, you could find the voltage drop in that resistor. You could find the power consumed in that resistor, or you can find it for the whole circuit. It just depends on which R you put in here. RT would give you the voltage, the current for the whole circuit. And then say if you did V equals IR3, that will give you the the voltage drop over that specific resistor. Okay, so that's why you end up doing a lot of work with R total, figuring out what R total is, because you want to try and replace this complicated circuit with a simpler one so that you know the power consumed, or you can find the power consumed in the entire circuit. And that's generally the direction that most of the problems go. So also commonly you're going to see the total resistance written with the sum sign. So it'll be R sub n equals 1 to n equals the total number of resistors, right? Which would, R1 plus R2 plus R3 plus ... Same thing with the 1 over R for the resistors in parallel. So let's work one of those problems. Say we have a circuit and we want to find the power consumption of the following circuit. And then they give you this little circuit right here. 24 volts. got 10 ohm resistor right there, 15 ohm right there, and another 10 ohm right there. Okay, so this is a circuit with parallel resistors, right? And if we want to find the power consumption of the entire circuit, it's easier to replace these three resistors with a singular one that has an equivalent resistance of these parallel resistors. So the first thing we want to do is find our total. We know that 1 over our total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Actually, we'll leave. Let me do it like this for a minute. So now you're going to get 1 over RT is equal to 1 over 10 plus 1 over 15 plus 1 over 10. If you plug that in, 1 over 10 plus 1 divided by 1 divided by 10 plus 1 divided by 15 plus 1 divided by 10, the number that you get is 0.2666, just repeating, right? And so, doing just as we said, 1 over RT, so we take 1, we divide it by that side. This is the reciprocal operation, so we're finding the reciprocal, right? 1 divided by 1 over RT is just going to give us back RT. And then 1 divided by 0.2666, repeating, is going to give us the reciprocal of that. And so what we end up with is RT is equal to 3.75 ohms. And that gives us our total. Realistically, what we've done is we've made this into a simple circuit. Now we're just looking at this one, which got RT and voltage. And now we can talk about the current that is going through the circuit. Because up here before in this example, you got I coming in here, but really you have I1, I2, I3, and I total is equal to I1 plus I2 plus I3, okay? That's not very easy to deal with, so you make it simpler, okay? Whichever direction it flows. Can't remember how this ends up, if that makes it the negative and the positive side. Not important. We don't care today. Alright, so now we've got this, and we can come back to our V equals I R. This is total, right? And so what is easier sometimes to do, don't rush to put numbers in. V divided by, if we divide both sides by RT, those cancel, and now you have V divided by RT is equal to I. So now we can put our numbers in. 24 volts, and then 3.75 ohms is equal to I. So I is equal to 6.4 amps. Okay? Now, we didn't actually have to do that, and I'll show you here in a minute why. But now that we have that, power is equal to IV. So we can just put P is equal to 6.4 amps times 24 volts. And that's going to be equal to 153.6 watts. Okay? And that's your answer. But once we had our total, we actually didn't have to do that, because if you have these two equations, so you have V equals IR, you have P is equal to IV. So long as you have another expression, you can't plug the same equation into itself. But V equals IR is a totally separate relation. So there's a V here, there's a V here. So if I put I and what V is equal to in here, IR, you get that power is equal to I squared R. So once you had our total, but you didn't have I, so what else could you have done? There's another relation. So I is equal to V divided by RT, right? So now, if power is equal to IV, that means that it's actually equal to V over RT times V, which is V squared divided by R subtotal. Okay? So, we didn't have to actually find I, but it's typically the way they teach it, and it's confusing to try and remember all these, but if you like it, go for it.